I did it!
Did what?
I climbed this mountain!
Huh.
In this video, we're going to cover angle proofs, which is proving a set of angles are congruent to each other, and how to appropriately plan out a proof before actually proving something. Now, before we get to actually proving a set of angles congruent, let's go over the 8 ways in which we can actually arrive at that conclusion, the theorems, definitions, and postulates that allow us to make the conclusion that a set of angles are congruent. Now, we've covered a lot of theorems, definitions, and postulates so far this year, so I'm going to pull up a list of each of those, and I want you to look over this list, which is every theorem that we've basically covered so far this year, the notation we use to abbreviate it, the page number you can find it on your textbook, and if the textbook has a different name for it, what the textbook calls it. So I want you to look over this list. If you're unfamiliar with any of these theorems, I want you to go back to your notes and see how they're used and what they say, or you can go to this page in the textbook to look them up. Look over each of these, identify the 8 that you think justify a set of angles being congruent, and then we'll go over those in a minute. So pause the video and do that now.
Uh-oh, guess what day it is? Julie, Julie, guess what day it is? Julie, Julie, guess what day it is?
Okay, so let's go back. The first way to prove a set of angles is congruent is from the definition of angle bisector. Recall that if a ray is bisecting an angle, it cuts the larger angle into 2 congruent parts, or 2 congruent halves. So that's one way I can get a set of congruence among angles. Another way is if I have a set of right angles, all right angles are congruent. That's the right angle theorem. You could equivalently refer to this as the right angle theorem. You could write either this or this in a reasons column of a proof. Another way to conclude 2 angles are congruent to each other is through the transitive property. Another method for proving angles congruent is the vertical angle theorem. If I have perpendicular lines, they form congruent adjacent angles. Supplements of congruent angles are congruent, which should also remind you of the complements of congruent angles being congruent. Now, I purposely left number 4 for last because it's one that's easily overlooked, and it's actually the reflexive property. Any angle is congruent to itself, and that's one that's going to come up once we get to triangle proofs. It comes up quite a bit. So those are the 8 ways we can conclude that angles are congruent to each other. So let's look at an example and see how these reasons could be used in an actual proof. So here's an example of an angle proof. This is actually can be found on page 62, number 9 of your textbook. So what I've done here is I've given you a statement bank. So all of the statements that are going to go into this proof, I've actually given to you. They're just not in the correct order. So what I'd like you to do is to properly arrange these statements in a valid order and then justify why each of those statements would be true. So I would like you to do that, and remember, before you ever begin a proof, you should always have a plan of action. So analyzing this given information, labeling in your diagram before I even begin to organize my ideas. So pause this video and do that now.
Guess what day it is? Guess what day it is? Anybody? Anybody? Guess what day it is? Guess what day it is? Anybody? Anybody?
Okay. So before I begin figuring out which statement's going to go where, I'm going to label my given information in my diagram. So I know that AC is perpendicular to BC. So here is segment AC, here's segment BC, and I know that these 2 things are perpendicular. Well, those being perpendicular mean that angle 1 and angle 2 would add up to be 90 degrees, which makes angle 1 and angle 2 complements of each other. Well, if angle 1 and angle 2 are complements of each other, and angle 3 is also complementary to angle 1, then since angle 1 is the same as itself, angle 3 would have to be the same as angle 2. So that's my plan, and now I'm just going to basically more formally write that up in my proof. So the first thing I started with in this diagram was that the 2 things are perpendicular, and that was given to me. From them being perpendicular, I made the conclusion that angle 1 is complementary to angle 2. So now I have to go through that long list of reasons in my proof, in my list of theorems, definitions, and postulates in order to figure out why this is true. And there is actually one theorem which allows me to jump right to that conclusion, and it says if the exterior sides of 2 adjacent angles are perpendicular, then those angles are complementary to each other. Notice that side AC and side BC are the exterior sides of angles 1 and 2, and since they are perpendicular, those two angles, 1 and 2, will be complementary to each other. This is a theorem that actually saves us a lot of time and energy when we're doing proofs. Otherwise, it would have been 3 or 4 steps longer. Okay, after I have that, I'm going to bring in this other given, the fact that angle 3 is complementary to angle 1. It's just given to me. And now since I have a set of complementary angles, 2 sets of complementary angles, and I know that angle 1 is the same as itself by the reflexive property, since angle 2, I'm going to use a highlighter to make this a little bit more clear, since angle 2 is complementary to angle 1 and angle 3 is complementary to angle 1, these complements of congruent angles will be congruent to each other. Complements of congruent angles are congruent. I can conclude what I was trying to prove, that angle 3 would be congruent to angle 2. Okay, so that is basically how angle proofs are done. Now we're going to go over 4 more examples of this in class tomorrow, so make sure to bring your packet with you.
Uh-oh. Mike. What day is it, Mike?
It's hump day.
Hump day? Woo-hoo!